Hi kids. In this video, this is a video all about evaluating and addition and subtraction expressions. This is topic 4.2. And what we're going to do is we're going to first talk about, I'm going to just kind of like indicate what this is all about in terms of the Common Core standards. You'll notice that it talks about fluency and addition, subtraction, multiplication. That's essentially what this lesson is about. They're talking about subtraction and addition expressions, but really it is also a pretty good focus on your fluency for doing basic computation, okay? As I know, sometimes you think, well, we really don't need to have fluency, but really the Common Core does expect you to be fluent in addition, multiplication, and subtraction, as well as the PA Common Core standards. So anyways, let's get right down to it and take a look at what we have. Okay, in your book, it goes over the evaluating addition and subtraction expressions, and they ask you, how can you add whole numbers and decimals? So that's the actual computation skills we will be addressing. And as always, they give you a problem, and they say to you, Kim and Martin swam 50 meters. Martin took 2,600 seconds longer than Kim. And then they ask you to answer this question. What was Martin's time in the race? Okay, so in order to figure this out, you're going to choose an operation and add to find Martin's time. So in other words, what we know is we know that Kim's time is 50 and 9/10 seconds. Martin's time is 26 hundredths of a second longer than that. So then we're going to go on and we're going to see how the book solves it. And what they do is they say, find 50 and 9/100ths plus 26 hundredths. Notice how they ask you to estimate first by rounding each addend. So, earlier in this lesson, in this topic, we discussed and we practiced adding and estimating. And so now they want you to actually apply it. So what they're going to do is they're going to round 50 and 9/10 to 51, and then they're going to round 26 hundredths to a more usable number, which is 3/10, and they will get an estimate of 51 and 3/10. Okay, so that's kind of, and the point there is that that's part of our fluency is to kind of know what you're going to get before you actually do the computation. So then they go on and they review the skills and they say, find the sum. Sum means the answer to an addition situation. Line up the decimal point. So this is a really, really important thing, and that is you should always line up your decimal points so that your place values have the correct correspondence. In other words, the hundredths line up with the hundredths, the tens line up with the tenths, the ones and the tens all line up as well. Okay, so it's really, really important that you do that. Notice also how they say to annex a 0 to 50 and 9/10 so that each place has a digit. Okay, so that's just simply so that you kind of keep track of what it is you're doing. That becomes very important when you're doing subtraction with decimals. All right, so anyways, the book then goes on and they actually do the computation and they say at each place value you can regroup the sum of 9/10 and 2/10. So you can see that the addition of decimals is pretty much the same as the addition of whole numbers, but what you want to remember to do is bring down your decimal point. All right, you want to bring it straight down and put it in the correct place in your sum. All right, so the answer to this problem, Martin swam the race in 51 and 1/1600 seconds. The sum of 51 and 1/1600 seconds is close to the estimate of 51 and 3/10. So your estimate and your sum actually add up. And then you'll notice in the book, they go on to give you another example, and they ask you again, how can you evaluate expressions with variables and decimals? Well, the same way that you would do it if you didn't have decimals, okay? And then the example problem is, Kate ran a race 2,500 seconds faster than Asha. Let A represent Asha's time. Evaluate the expression A minus 2,500ths to find how fast Katie ran the race if Ash's time was 20 7/10. Okay, so again, what they're doing now is they're using substitution for one value so that you can continue to evaluate the expression. Okay, so what you do is you substitute 20 7/10 for A in A minus 2,500ths. So then you simply would then estimate to find the difference by rounding, and what they do is they're going to round the 2,500ths to 3/10, and then they're going to subtract that from 20 7/10 to get the 20 4/10 as a reasonable estimate. Now, notice then that once they came up with their estimate, they're then going to find the actual difference. And so again, you line up the decimal points. You'll see that they're lined up right there. That's really, really important. And then you'll notice they tell you to annex a 0 as a placeholder. So that becomes really, really important in subtraction, because that gives you something to regroup and borrow from and regroup over. All right. So then once you've got things set up, then what you're going to do is subtract each place, regroup the 7/10 to subtract the hundredths. So notice that you pretty much ignore the decimal point. You're just going to bring that down right into your final difference or final answer, but you do all the other calculations like you would with whole numbers, okay? And so when you're done, you have your answer of 20 4500ths. Katie ran the race in 20 4500 seconds. 20 4500ths is close to the estimate of 20 4/10. Okay, so there are your example problems. So now what I'd like you to do is I'd like you to try some of these problems, all right? I would like you to pause the video, and I would like you to try number 1 right now. So pause the video and then start it when you're ready to see if you got it correct. All right, here we go, kids. The answer to number 1 is 8 6/10. We know that because if we take 5 9/10 and we add it to 2 7/10. Notice how I lined up my decimal points. 9 plus 7 is 16. Regroup across the decimal points into the ones place. 1 plus 5 is 6. 6 plus 2 is 8. Bring down your decimal point, and there's your answer, okay? Go ahead and pause the video and try number 2. All right, the answer to number 2, your problem is 4 100ths. Take away 2 9500ths. Again, it is just the standard setup. Okay, so you would have 4 100ths. Take away 2 9500ths. Notice how my columns are relatively neat. My numbers are line up in correct correspondence. And so now you have to do the same algorithm of borrowing and regrouping. You can't take 5 from 1 or 9 from 0, so you're going to borrow from the 4. It becomes 3. The 0 becomes 10, but you borrow again, so that becomes 9. Then you have 11 over here. 11 take away 5 is 6. 9 take away 9 is 0. Bring down your decimal point. 3 take away 2 is 1. So there is your correct answer. All right? I would like you now to pause the video and do number 3 and number 4. Do them both and then start the video up and we'll go over them. Okay? Alrighty, let's see how you did. For number 3, you have 2 5700ths added to 7 706,000ths. Your answer will be 10 276,000. thousandths. Now, this one you might have struggled a little bit, but remember what you want to do is you want to set up so that you have your corresponding place values in the correct alignment, which means that the 7 and the 2 are going to align in the 1's place, and then you have the 706 thousandths lined up underneath the 57 hundredths. Now notice I'm going to annex a 0 just to kind of make this, just to keep myself on track. 0 plus 6 is 6, 7 plus 0 is 7, 5 plus 7 is 12. Regroup across the decimal place, or the decimal point, and then of course 1 plus 2 is 3, and 3 plus 7 is 10. Okay? All right, number 4. Let's take a look at number 4. The answer is 8 and 892 thousandths. This one is a little bit different because you have 15, which is a whole number, and then you have it taking away 6 and 108 thousandths. And you'll notice that you have 3 zeros to annex in this situation, and then you're going to regroup across multiple digits because you're actually going to have to start at borrowing at the 1, which will become 0. 5 will change into 15, but you borrow from that, so it drops down to 14. Because you want to make the 0 in the tens place 10, but you're borrowing from there to make 10 in the hundreds place, and you're borrowing from there to make 10 in the thousands place. So now you have 10 take away 8 is 2, 9 take away 0 is 9, 9 take away 1 is 8. So now you're done with the decimals, and now you have 14 take away 6 is 8. And so there you have your answer. All right, let's have you try 2 more example problems. Try 5 and 6, but this time you're going to use substitution to evaluate the expression, okay? See if you get these correct. All right, here we go. Let's take a look at number 5. Number 5, the answer is 444 thousandths. Again, now the expression is P take away 1 and 56 thousandths, and P equals 1 and 5 tenths. So what you have to do is you have to set up 1 and 5 tenths to take away 1 and 56 thousandths. And again, this is quite a process here. So you're going to annex some zeros, okay, up above there, and now you're going to borrow from this 5 to becomes 4. This will become 10, but you borrow, so it becomes 9, and you have 10. 10 take away 6 is 4. 9 take away 4 is 4. 4 take away 0 is 4. Bring down your decimal point. 1 take away 1 is 0. Okay, number 6, the answer to number 6 is 10 plus x, and x has a value of 3 and 284 thousandths. That's kind of a blurry 4 there, but we're going to do the math, and we'll see that, or you have 10 plus x, x equals 303 and 284 thousandths. Wow, it's a mouthful. So anyways, we're going to take 10, and we're going to add it to the value of x. 10 is a whole number, and you have 3 place values to the number you're adding, the value of x, which is 3 and 284 thousandths, and it's addition, okay? And so we have 4 plus 0 is 4, 8 plus 0 is 8, 2 plus 0 is 2, 3 plus 0 is 3, and 1 plus nothing is 1. So your answer is 13 and 284 thousandths. Wow, I got a little tongue-tied there. Okay, so anyways, hopefully you did a good job, and if you need more help, you can see your teacher, or if you're at home working cyber style, you can see your parents. Good luck, kids.